Hello everyone, I'm Qiyu, a third-year PhD student from UCSD. Today I've been talking about something I've been working on over the last 3 years, about turning privacy risk assessment into 20 questions for developers. So the central problem of this talk is about how to articulate privacy-related design decisions. When developers are building software, they have no idea about the specific details they are designing. Also about, they are not know what might be some potential alternative options. One example today is that if you use a cloud code to build a software, you just use a single prompt, and the AI coding tool will take over the job and build the entire software for you. And this may lead to many privacy fiascos. And this is a real-world example. It actually happens a few years ago. So Zoom rolled out an attendee attention tracking feature during the COVID-19 pandemic. And its initial goal is to tracking the participants' attention. And if they are not paying attention to the meeting content, and it will display a clock icon next to the participant's name. And after the meeting host will receive an email including the percentage of the times of the attention status for each participant. Of course, this feature received a huge pushback, but the problem is that how we can help developers think through such scenarios. So that's when our tool came in. So suppose I was the developer, I can type in a sentence like, I want to design an attendee attention tracking feature for a video conferencing app. Then our tool will automatically generate some multiple choice questions. For example, would the attention tracking be opt-in or opt-out for attendees? And each question will come with a list of concrete options, like opt-in, opt-out, and always on. And here we choose always on because it's the actual option in the Zoom case. And based on the option selected, the system will ask follow-up questions. For example, it will ask whether the attendees would be notified about the attention tracking. And it also has several options like just in time, at install time, periodically, or the participants will never be notified. And here we can choose the just in time because we want to prioritize the user experience. So the third question is about whether the host will be able to see the aggregated attention data or individual scores. Normally, this type of details are often ignored by developers, but here we can ask this type of questions to explicitly surface this design. And here we chose the individual scores. And initially, the Zoom want to apply this feature to K-12 education scenario. So another question would be whether this feature will be only applied in education scenarios, or it can also apply in some office settings. So following this process, we can derive a list of questions, like whether the data collection should be opt-in or opt-out, and what data should we present to the meeting host. Should we only show the aggregated data, or we show the individual scores? And should we notify the participants as install time, or just in time, or periodically? And whether we should restrict the application scenario to the education settings. Should the notification be always on, we have a daily notification to notify the participants about their tracking status, and how is the attention enforced? So we have this many design decisions, and the developers only need to answer the multiple choice questions generated by our system to figure out these low-level design details. So there are a few established privacy threat modeling frameworks, including PIA, Linden, and NIST Prime. We actually draw inspiration from all of them. They mainly follow a common paradigm, so it will first assess the system design by enumerating the data actions in the system, and then analyze the threats and harms associated with each problematic data action, then prioritize the risks to select mitigations and controls. So we conducted a study with the NIST Prime to understand the usability of this privacy risk assessment frameworks for novice developers. We recruited 12 participants, many including students and junior software engineers. And we provided one scenario to each participant and asked them to do a NIST Prime assessment using a sync allowed protocol. And here are our findings, and we identified 3 challenges in the Prime study. So first, we found developers often overlook important privacy-related design opportunities, such as who should have access to the attention data, and when should the user be notified. Second, we found that even if they are aware of the design opportunities, they often consider a limited range of the alternative options. For example, most participants assume that the meeting host will see the individual data, and they rarely consider alternative options like anonymized or aggregated summaries. And since each data practice can involve many design decisions, it is very hard for them to allocate the attention. Several participants spend most of their time focusing on one data action they are most familiar with, and as a result, they have little energy to think about the other parts. So, built on this, we designed an interactive tool called Privacy Akinator. And its core idea is to use large language model to generate dynamic questions to help developers articulate privacy-related design decisions. So here's the state of art for privacy risk assessment framework. And it is called Linden. And Linden can identify 7 types of threats, and it will require the developers to create a data flow diagram and annotate the threats for each nodes and edges in the diagram. However, this process can be tedious, and the previous study found that it may require a lot of time to map these threats for all the elements. And the main problem is that this representation is a general diagram about the software engineering, and it is not specifically about privacy. So here's the data flow diagram. And we can see that here's the example for the Zoom attention case. And the Zoom first collects information from the attendee and then sends the data to the cloud server and shares the information with the host. However, we found that this type of diagram, they are mainly general purpose and they do not cover the necessary privacy-related details behind this data flow. And in HCI theory, we found that we often see that a good representation can help make people smarter. And a good representation should capture what matters for the task and deliberately omits for the rest. When we think about privacy, there are two essential things. First is about data flow, which describes how the data moves through the system. And second is how the stakeholders interact with the data flow. So building on this idea, we designed a verb-based representation for privacy, where each node in the representation is a verb. For example, we still use the Zoom attention case. It will first collect the application focus state from the users, and then process the attention status and generate the attention scores and stores the attention data on its server. Here, collect, process, and store, all these are the verbs. And stakeholders can also interact with these data actions. For example, the host can control whether the attention data collection is enabled. And it may also involve notify and consent mechanisms, such as notifying the users when they lose attention over an extended period. And each data action or stakeholder interaction has a few properties. And we ask developers to explicitly articulate these design decisions associated with each node. For example, collect may have data type, frequency, timing, and method. We then use the data-driven approach to mine a privacy design space. We first collected 10,000 privacy news articles from the internet, and then extracted the privacy design decisions from these articles, such as here in the Zoom case, it collects the active window status, and this feature is enabled by default, and there is no notification mechanism, and so on. And we group by them by the data action and stakeholder interaction to put in our taxonomy. And we finally use an iterative open coding process to derive our taxonomy. And in each iteration, we use the large language model to first extend the available options for the existing privacy design decisions, then try to discover entirely new decisions. And we repeat this process until the design space saturates. And here's our resulting taxonomy. And using this approach, we can get a data-driven privacy taxonomy which describes the potential properties for each data action and stakeholder interaction. For example, the collect may have the properties of location and frequency. And due to the time limits, I won't go through this in detail, but you can find more information in our paper. Now we have all of this, we can dynamically generate the questions. And our system generates two types of questions. So the first one is exploratory questions. For example, here the question asks, would the users be notified before their attention status is collected? And the user can answer yes or no. And if the user answers yes, we will add a new node to the representation and attach it to the collect node. We also have the exploitative question. And the general idea is that we want to infer the properties for the existing nodes. Here, the question asks, how long will the attention data be retained after processing? And we use the large language model to generate concrete options adapted to the developer's context. For example, here the options might be during the meeting, 24 hours, 7 days, 30 days, and developers can also write custom answers. And after developers answer the question, we will dynamically update the representation. We conducted a user study with 24 students and junior developers to evaluate our tool. We asked them to identify privacy-related design decisions for two scenarios, and we used the NIST Prime worksheet as the baseline. We also recruited a group of privacy experts to establish the ground truth for the important design decisions in each of the scenarios. And here are the results. We found that our tool works better. So first, it can help developers identify more privacy-related design decisions. Participants obtained a coverage of key decision of 89% using our tool, compared to 42% using the baseline. And it also significantly reduced the cognitive load for developers. Participants perceived significantly lower mental load, effort, and frustration when using our tool. So I've been talking mostly about the assessing system design so far. And moving forward, I'm going to talk about the next steps. And we are currently working on how we can analyze the threats and harms associated with each decision, and how we can prioritize the risks and select the mitigation and controls. This is likely to be my dissertation topic, and I've been working on this problem for about 3 years, and I'm very excited about using AI technology to improve privacy threat modeling. And if you are interested in using our system or would like to give us any feedback, feel free to contact me through the email here. Thank you.